Welcome to Hello Fort Winnie. I'm your host, Tom Dunn, and today we have a special program. And if you recall, a few weeks back we had an earthquake, and it was quite two of them, matter of fact, excuse me, and both of them were unique and different. And with us today is Brian Fig, and he is going to teach us a little bit about earthquakes. Welcome, Brian.
Nice to be here, Tom.
Brian took a couple earthquake classes at Cal State University, and there's a lot about it that we don't understand. People write about it in the paper, but I think you have some information that will really be beneficial about understanding earthquakes, what to expect, and also how to prepare for them.
Well, that's right, Tom. I, was replying to a couple of the comments on the Facebook feed to Tom Dunn's post, as a matter of fact, when the earthquakes happened, and I noticed some misstated information. I think that just comes from a general lack of understanding, and my hope today here is to clarify some of that. So, the first thing is the two earthquakes were not actually individual earthquakes. They were part of what's called a sequence or an earthquake sequence. Because it was happening on one fault, all the earthquakes were connected in this period of time, and therefore that binds them together in a sequence. So the first earthquake, if I remember the magnitude correctly, it was a 6.4.
Right.
That was at the time considered what is called the main shock, or the largest earthquake in the sequence. But that changed when the 7.1 happened. The 7.1 became what's called the main shock, the largest in the earthquake sequence. Now, some of the general mistakes that I saw were labeling foreshocks as aftershocks, and the main shock as aftershocks. So what I intend to do here is describe to you what a foreshock and an aftershock is. So as I've already stated, the main shock is the largest in the sequence. Um, Smaller earthquakes that are smaller than the main shock that come before are called foreshocks. Smaller earthquakes that happen after the large earthquake, the largest in the sequence, is those are called aftershocks. Now, the reason why terminology is more important is because when you're in the middle of an earthquake sequence, if you're impacted by one of these earthquake sequences, it's important to designate the name correctly because for all you know, a larger one could be coming. So it is very crucial to name these earthquakes with the proper terminology to make the neighbors aware.
Aren't usually I'll call them foreshocks now, minor in the power they have, and the 6.4 is usually the big one because you had a couple minor ones.
Mm-hmm.
So this one, to have another one even bigger, unusual.
Well, it is, yes. To answer the first part of your question, foreshocks don't necessarily have to be small in size. So, for example, I turn back to the Chile earthquake in the early 2000s, if I remember correctly. It was a 9.7, but the foreshock was an 8.0. So there was a foreshock that was an 8.0. So to say that foreshocks are small isn't actually an accurate statement. It's smaller than the largest quake. Now, to answer the second part of your question, it isn't uncommon to have a larger quake come after. It is rare in that because it only has a 5% chance of triggering. 1 in 20 earthquakes will trigger a larger one. So yes, it is rare, but to see one of this scale, it is certainly not something we've seen in California.
You know, most of us are, at least coming from the Bay Area, I've been down here now 15 years, and I still don't know the faults down here, but up there we had San Andreas and the Hayward, which pretty much still extend down here. What fault was this one on?
This was actually a particular fault called the Ridgecrest fault that just runs right under the city. So as we know, California is a very geologically active area. There are many different regions with various different faults. There's three different types of faults that we mainly have here in California, and they're all of the strike slip variety for the most part. And that is right offset, left offset, and all those are just depends on which way the fault slides, the plates slide next to each other. And dip slip, which are vertical, like the one in Northridge. That's the one that caused the mountains to go up a little, and everybody remembers the
That
earthquake.
was the last major one we had, and it's been, what, 25 years almost?
Yeah, about,
About.
if I remember correctly. Yeah. But those are the three really major types of faults in California, but there are others too, like thrust faults, We have a whole area in the Mojave Desert called the Eastern California Shear Zone that's all, individual faults that are there. So in terms of major fault impact, like the Hayward, that's a major fault in the state of California. San Andreas and Hayward would have no impact by these particular earthquake sequences that we felt here. However, the Garlock fault would. The Garlock is only about 10 miles south of where this earthquake was centered, and the Garlock I can't really speak much to. It's a very, very silent fault. There isn't a lot of information in terms of earthquakes and mechanics of the way it works because it is such a silent fault. It's never.
Is it possibly called a young fault because of the others are so much older, you have more information because there's been more quakes?
It's not necessarily a matter of age. I'm pretty sure the Garlock is pretty old. I'm not necessarily certain to the specific eras. It's one of those faults that has been very, very, very quiet. We have records dating back to the 1850s, and there's been no major quakes on that fault in particular. So I would not the age really has nothing to do with it. It's just we don't know what the recurrence interval is, and the recurrence interval is how many large quakes it can produce in a period of time. So, for example, the reason why we're able to predict a very large earthquake, the big one on San Andreas, is because of its recurrence interval. We know how often and how large these earthquakes can get on the San Andreas, and we know that it's overdue for a large one. But we don't know that for the Garlock. So the one thing that these sets of earthquakes tell me is that region is still geologically active, and we should not discount any potential earthquakes coming from the Garlock.
Have we had one out in that area in the last 100 years that we would recognize, 5 point or higher?
There have been a couple. There's been the Big Bear quake, which is up in the mountain area of that region. I'm not too familiar with that particular part. I'm more familiar with the Eastern California Shear Zone, which is south of the Garlock, whereas opposed to the northern part. So maybe I'm not too familiar with the data, but it's certainly possible. I wasn't born when Northridge happened, so I don't have the same memory of events as other people. But I could certainly get more information available to the public if you wanted me to.
One of the, quote, good things about the Ridgecrest quake was that is out in a lesser populated area, buildings maybe 2 or 3 stories top, and I would imagine if a 7.1 went directly under a major city, it's going to do some damage.
Well, yes, but it also depends on the earthquake codes as well. Every time there's a large earthquake and structures are damaged, the earthquake codes are updated. It's one of those things that we have some of the strictest regulations in the country when it comes to that. As a matter of fact, this house that we're sitting is perfectly set for an earthquake because it has lots of shear walls, which is a way to defend against many of the higher energy waves.
Aren't there some, I'll call them skyscrapers, not that we have any out here, but they go up 40 stories or so in LA and San Francisco, that the buildings actually are built on rollers a little bit so that they can move a foot or two without having a stressful point that would cause it to collapse?
Well, that also depends on the age of the structure too, when it was built. So that's more of a recent engineering
How recent?
breakthrough. I'm going to say mid 2000s, and maybe a little bit prior. But like I said, I'm not too familiar with the engineering aspects of it. I know basics like bolting your foundation to the bottom of your house. That is one of the cheapest, most effective ways to save your property. Now, when it comes to large scale structures, I am not the guy to talk to. I can't speak even in semantic terms about it.
So what you studied was mainly just the geological effects, and I am interested in that. Immediately they were able to say that there was a 5% chance of another quake when it was a 6.4, and by golly there was. And this one guy on TV said, well, it's 5%, here it is, that's how you get it, one time in a lot, and you get that ready to happen. So I think in talking to you earlier, you did mention that never be sure that there's not more coming. Don't just immediately go back to where you were or something. Listen to the radio, TV, emergency broadcasts, and what's going on.
Yes.
And that leads us into our next thing, which is how do you get prepared for that? And I'll let you describe it. I did Google American Red Cross, and they have a wonderful site for emergency disasters, what you need to be prepared with, what you need to keep in stock. And there's a couple levels of that. Can you explain that to us?
Well, what they're doing is they want you to have a permanent preparedness kit for any disaster, not just earthquakes. And they include all sorts of things, a gallon of water for each person. And it's dependent on how long you're going to be here. So if you're getting your things and evacuating, you want to have 3 days of water available to you. If you're staying behind, you want to have 7 days of water available. So it just depends on what your game plan is after you leave, and you can use the Red Cross. They have amazing amenities, not necessarily amenities, but guides.
They,
Um,
yeah,
but there's other things you can do too.
yeah. Have a supply of food for how long?
Yes.
What type of food? Be it, I'll call it C rations, which they were called, I think MREs now or something like that. Medicine,
Yes, medicine. Have everything ready for your dogs and animals as well.
also medical histories. I found that interesting because if you do get injured and you're in shock or you're out and a rescuer comes by, you'll have that information nearby. And why don't you tell us too, which I found very interesting, is to have a supplemental pack
Correct.
next to where you sleep. Explain that.
Well, I think you misunderstood the two things I was saying. The first thing is I would want people to have would be a pair of shoes right next to their bed, away from the windows. Because if there ever was an earthquake or something that shattered the glass near your room, you wouldn't want to walk on shattered glass. You'd cut your feet and you wouldn't be able to walk. So having an extra pair of shoes away from the window is going to be crucial in a disaster. The second thing I would have also is what's I call a go bag. It's going to have tax documents, your birth certificate, a medical history if you can get it,
A little water and food.
water and food. It's going to have everything you need if you just need to get up and go like that. If you need to, like in the case of an earthquake or a tsunami, where you don't have time to get to your permanent preparedness kit that the Red Cross has, having something in a backpack waiting for you where you can just pick it up and get out before the SH hits the fan.
You may have to go through the window.
Yes.
You know.
Yeah.
So there is all kinds of disasters, can happen, especially like down here where we live. Besides earthquakes, there could be a tsunami. Highly unlikely, but there is a chart in the city hall that says, I don't know, was it 60 years ago or something? They had some waves here, and it tells all about it. So
So tsunami risk, we happen to be one of the most unique areas on the coast that we are right next to tsunami generating faults in Santa Barbara. For the most part, the rest of the state is clear except for foreign waves. So like that from Japan, there was the waves reached all the way to San Francisco. They weren't very large, but they still reached San Francisco.
they were larger up north, towards Butte County and Oregon. That's closer to Japan, and so they got the brunt of it.
Yeah, but it wasn't that large because it was from Japan. They had a lot of time for the wave to dissipate on it. But so tsunamis are a definite risk here, and particularly in Ventura and Santa Barbara counties. Also in the northern parts of the state too. If any of the people that are listening to this have properties, you have the the Cascadia subduction zone, and that's up at the very northern tip of California, and it goes all the way through Oregon up to Seattle. And the last time that ruptured was believed to be feudal Japan before 0 BCE. It was reported in ancient Japanese calligraphy that a wave had hit their coast without a quake. And it was now that we have the beautiful geologic studying equipment, we have the ability to see that the sediment that was deposited in Oregon and Seattle matches that hits Japan. So there was a wave that was generated right off the coast of the United States that hit and destroyed many parts of Japan in the 1600s.
Well, the latest one they had, or sometime in the last 10 years, I read about it, they had, and it took maybe a month or so for the waves and stuff to fully get here, and they found fish that were not normal to the Oregon, Washington, Northern California area. They came from Asia.
That's true. We also had fishermen boats that were off the coast as well. We also had some other concerns too with the Fukushima that it would spread some of the radiation. However, thankfully, nuclear meltdowns don't happen that quickly, and it wouldn't have been able to carry it in that amount of time. But it's serious concern is tsunamis when you live on the coast,
Yeah.
no matter where you are.
Be sure to Google American Red Cross and be as prepared as you can. And thanks for listening about this. We hope it was very informational. Brian, thank you very much.
You're welcome.
College is going to pay off.
Yes, it will.
All right. Thank you guys, and we'll see you on our next show.
Have a good one.